October 29th, after months of quiet preparation, a web of observatories waits for the same instant, the moment 3I Atlas reaches Perihelion, where sunlight becomes the purest test. Models have promised a smooth crest in brightness and a graceful fade, the familiar arc of many well-behaved passages. Yet at the decision point, the light does not swell and soften. It knocks 3 times in evenly spaced rises that sit like a small signal inside a sea of glare. No one names the signal. They simply stay with their screens, keep the room still, and record each second. For that brief flicker to carry meaning, the story needs to open again at the beginning, in the earlier hours when everything is plain and within expectation. At the edge of the heliosphere, where the solar wind thins and galactic dust speaks more softly, a faint point enters nightly survey grids. 1 weak stroke near the noise floor, then another hours later, enough for motion to turn a straight guess into a gentle arc against fixed stars. There is no banner and no drama, only the steadiness of change. The sky remains calm. The record begins with patient dots. The line between 2 nights curves as data thickens and energy hints at a path that will not close around the sun. The minor planet center receives times and coordinates and combines them with its usual deliberation. The International Asteroid Warning Network adds the track to shared dashboards, not for hazard but for continuity. At the Planetary Defense Coordination Office, analysts fold the newcomer into the background rhythm of follow-up and refinement, not an alarm, only an exercise in understanding. Telescopes widen cadence and sharpen accuracy. Astrometric teams refine reference stars, correct low-altitude refraction, and trim biases small as dust. Each measure spans a handful of pixels, but gathered together the numbers speak the same language. Brightness climbs by geometry alone. There is no tail yet, no soft coat of coma, only a compact nucleus, perhaps a few hundred meters across, turning in a way the instruments cannot yet disentangle. Color stays discrete, not bright with fresh ice, not reddened by very old dust, a disciplined gray of early days. The quiet of the data is here the most generous gift. The boundary where solar influence fades lies behind it now. As distance closes, the medium changes character. Charged particles stream inward and drape around the guest. Plasma instruments note a mild disturbance precisely where prediction places it. The point remains a point. It draws nearer from the domain of distant comets into the inner map, where spacecraft keep schedules and radio arrays share time. High mountain observatories pass the track between longitudes. Clocks are cross-checked until drift dissolves into the noise. Predictive software learns this object's cadence and reflects it back in nightly windows. Everything stands in its place, noise timing and a promising stroke of motion. Plans take shape around solar conjunction and perihelion. Coronagraphs rehearse how to hide the disk and open the corona at the right hours. Spacecraft planners set roles so panels and antennae keep safe attitudes while cameras look as close to the light as design allows. Ground facilities accept the pause of glare and prepare to hand the record to orbit. The Hubble Space Telescope holds a contingency lane for resolution if geometry permits. The European Southern Observatory reserves a run of nights for color and light curve. Solar missions widen their fields to welcome a small visitor crossing the bright weather of the sun. All of it is orderly and unhurried, the rhythm of a discipline that trusts persistence over spectacle. Naming follows procedure. The working tag becomes a designation that carries the interstellar marker. Atlas drawn from the survey that first reported motion anchors the name in shared practice. 3I Atlas brief and sufficient places the body within a lineage opened by a dark shard and then a pale comet. The ledger of the sky is patient. It accepts the entry without comment. A name does not explain. It locates so that questions can start from a place that can be found again. Public circulars remain measured. One notice, then another written in language that asks for additional observations and avoids thunder. Skywatchers add the new line to their night list with the same care they bring to returning asteroids and blooming comets. The object approaches no planet closely. It raises no concern. Interest is strictly scientific and quiet to watch how a visitor from beyond behaves inside this star's inner weather. Calm is not indifference. It is the chosen tempo of a craft that knows endurance is the way through the long night. Weeks pass and the light curve thickens with points that sit comfortably within the limits that seeing allows. Photometry corrects for error, for phase between sun object and observer, and for the small imperfections each instrument carries. Brightness rises by the slope expected for an approach of this size and reflectivity. No significant coma appears. If outgassing waits, it waits for heat. If structure lives at the surface, it remains hidden inside a single point, even to mirrors above the air. The baseline becomes clean. Baselines are what future surprises will need. The interstellar marker adds a quiet tension at the edge of routine. Memory reaches for earlier visitors in the corrections they pressed upon models. Teams test pipelines with synthetic stars and moving ghosts so that oddities, if they come, will not be tricks of code. They rehearse merging across hemispheres and handing off as Earth turns. The cadence of observation becomes a heartbeat, slow and regular, a peaceful presence woven into the shift schedule. There is no drama in the frames, only the comfort that careful practice cultivates when it intends to listen a long time. In the last nights before the sun takes the line of sight, the track leans inward across constellations that once guided ships. Each evening the object sits lower, nearer the pale tide of dawn. It remains a point. No wings, no fans, no plume. That absence is expected. Distance and geometry hide faint breath from even sensitive instruments. Schedules firm. Calibrations are checked twice. A network that spans continents and orbits finds its balance. When glare arrives, the record will pause only briefly, then continue from other vantage points with other tools, each tuned to catch what the next hours may hold. What arrives to this point is simple. A traveler from far away steps into the sun's domain. It asks nothing, it feels no need to declare. It presents itself to the ring of watchers that encircles this star, and they answer with measurement. In that balance, the event takes a first shape. Before strangeness gathers, before any curve deviates from prediction, the scene is a study in method. An object approaches, instruments listen, the sky holds steady, and then in that steady music, a small drum beat begins, 3 rises spaced like thought light enough to soothe, clear enough to remain. Night by night, the early measurements thicken into a real path. Survey exposures arrive from different latitudes and seasons, stitched together by a shared habit of precision. Technicians check flats and darks, watch seeing fall and rise like a tide, and confirm that the faint point is not a trick of electronics or sky. The centroid settles within subpixel tolerance, and the motion between frames remains smooth. The tale of distance writes itself in tiny displacements, ordinary in appearance and quietly extraordinary in implication, as a line of light moves just enough to be distinct from the stars that hold their places. Astrometry takes the foreground. Reference stars are drawn from stable catalogs to keep distortions low, and plate solutions are tuned until residuals click into a narrow band. The field model accounts for subtle lens curvature and for the way air bends light when the object skims a humid horizon before dawn. Topocentric corrections place each observatory exactly where it stood when shutters opened. Heliocentric corrections place the sun where it was when the photons began their long walk inward. The measure of a path becomes the measure of the surveys themselves, tuned to speak a common language across oceans and deserts and winter ice. The minor planet center gathers times and positions and broadcasts updated elements with practiced restraint. Residuals shrink as more nights arrive. A first arc becomes a second, then a thread strong enough to carry forecasts across a week and into the following month. The International Asteroid Warning Network mirrors the notifications, ensuring that no single stormfront power cut or maintenance window breaks the chain. Amateur telescopes enter the record as deftly as national facilities. A small dome beside a pasture hands new points to a high mountain mirror. The shared table of measurement grows in quiet confidence. The object earns attention for how it does not behave while still behaving well. It refuses to drift into the familiar patterns of long-period comets that fall in from the distant reservoir around this star. Its inclination stays awkward with respect to the solar plane, and the small surplus in arrival speed suggests a home that is not here. Words like inbound and interstellar appear in notes as calm descriptors rather than headlines. Labels follow evidence, evidence follows patience. The motion is simple enough to be soothing, and yet it leaves room for wonder to settle without hurry. Color measurements begin to separate the glow, filters slide into place. Exposure times are stepped gently to keep signal near the comfortable middle of each detector. Spectrographs take narrow swaths of light and lay them down as soft hills across wavelength. The first impression shows carbon and dust in conservative ratios, nothing too cold, nothing too fresh, a surface that has traveled and endured the slow abrasion of space. The result supports the idea of a compact nucleus, perhaps with a sealed crust, perhaps with volatile pockets that have not yet found a way to breathe. Everything remains plausible and modest. Instruments that do not make pictures add their part. A radio dish listens for emission that would hint at plasma meeting magnetic fields. The noise remains steady, a comfort rather than a disappointment. A radar facility considers a ping, but the geometry is unkind and planners decide against spending precious cycles on a return that would be too faint to teach. The absence of extraordinary behavior at this stage serves its own purpose. Baselines harden. The calm record becomes an anchor for what may come when the sun grows large in the field and the physics of close approach begins to write in brighter ink. Inside reduction pipelines, human care and machine repetition meet. Software finds trails, subtracts sky, and models the way a star blurs in air and glass. Humans look at thumbnails and confirm that the algorithm is not mistaking a hot pixel for a body. Tiny systematic offsets yield to calibration. Somewhere, a graduate student notices that a particular camera warms by a fraction after midnight and writes down the correction. Somewhere else, a veteran observer recalls a stubborn pattern left by a bright star just outside the frame and masks it before it can creep into the residuals. Trust grows as the trims become small. Coordination widens. The European Southern Observatory plots nights around moonlight. A solar observatory prepares coronagraph fields to catch the object as it approaches glare. The Planetary Defense Coordination Office folds the track into routine awareness, even though impact models show nothing of concern. Teams that run spacecraft check pointing constraints and downlink budgets to see whether a safe glance might be taken during scheduled operations. The network spreads like a net stitched by many hands, each knot tied to a simple idea that continuity is its own kind of discovery. Timeline notes grow specific. The approach will carry the object behind the sun from the perspective of ground-based telescopes. Space-based platforms will keep the thread alive. The days around conjunction are marked with reminders to save raw frames to archive headers with extra care to keep clock discipline exact. Milliseconds matter when an orbit is defined by many small agreements. The culture of these preparations is patient and unhurried. It moves forward because it has practiced moving forward, and because practice is the quiet way a community takes care of its own attention. Public postings retain a tone that helps sleep. Short notices confirm the inbound path, the likely size range, the best windows for professional follow-up. Star charts appear that show a thin stroke of motion against familiar constellations. The name 3i Atlas joins these ephemerides like a new word in a language fluent in distance and time. Nothing alarming enters the prose. The world beyond the observatories remains largely unaware, which is appropriate in these early days because what happens is a conversation among instruments and numbers and people who have learned that calm is the best place to stand when the unknown approaches. Across the community, murmur reaches back toward earlier visitors that changed how models are written. A shard with a strange acceleration that did not match its shape. A pale comet whose coma felt unexpectedly clean. Lessons drawn from those episodes fold into checklists that now look ordinary. Keep the raw data, compare across platforms, note sky conditions with more care than usual, invite independent reduction. None of this feels dramatic. It feels like tending a garden before weather comes, not because a storm is certain, but because attention is a habit that makes all outcomes easier to bear. On the last nights before the sun takes the line of sight, the track leans inward across constellations that once guided sailors. The object sits lower each evening, nearer the luminous tide of dawn. It remains a point. No fans or wings lift from it. The absence is expected. Distance and geometry hide faint breath even from sensitive instruments. Schedules harden. Final calibrations are checked twice. A network that spans continents and orbits finds its balance, and the sense of shared readiness becomes a soft presence that rides with the dawn. What the early record offers is simple and generous. A traveler from far away enters the sun's domain and meets a system of watchers that has learned to be precise without needing to be loud. The baseline is clean, the clocks agree, the sky holds steady. The object continues inward at a pace set long before these cameras were built. In this calm, the story takes a deeper root. Whatever follows will stand against this foundation, and because the foundation is sound, even surprise will arrive softened by context, carried by preparation, and welcomed without haste. Within the first month, the dossier around the traveler becomes orderly. Catalog entries line up with internal notes, and working groups turn a scattered set of images into a living file. The Minor Planet Center assigns the interstellar marker with the same deliberation it brings to every new designation. The International Asteroid Warning Network folds the track into its shared dashboards, not because hazard is suspected, but because continuity lives there. The Planetary Defense Coordination Office ensures that timings and sky windows circulate where they will be read. Names and roles are not ornaments in this world. They are the scaffolds that let many hands share one task without hurry. Context gathers around the name 3I Atlas. It carries the memory of earlier visitors and the changes they pressed upon models. The designation is a sentence condensed to a few words. The third interstellar object first seen by an automated survey that looks for change against a settled background. The phrasing is cool. It avoids metaphor and keeps the center of attention on observation. Under that calm surface, curiosity expands at a measured pace. An orbit that does not close an arrival speed that hints at long travel, a plane that is not the sun's own. Each becomes a page in the file written in plain language and mild ink. Committees and ad hoc circles define expectations so that deviations will have a clear frame. Photometric baselines are compiled from similar bodies that passed near to the sun or far from it. Thermal models sketch how a compact surface should respond to increasing light. Spectroscopic plans list the common volatiles and refractory materials, the signatures that say ice, dust, metal, or stone. Schedules carve out hours around dawn and dusk around moonlight and weather around the quiet churn of spacecraft commanding. The Hubble Space Telescope has a contingency plan for a look that would add resolution to shape the European Southern Observatory, tends a lane of nights for color and curve, and solar missions curate coronagraph fields for the moment when glare grows strong. Through this preparation, language stays precise and almost gentle. An interstellar origin means only that the orbit is open and the energy is right. Size remains a range until thermal inertia and reflected light can speak together. Rotation is a tentative guess based on small regular flickers that may belong to shape or to albedo, the way brightness differs across a surface. Every phrase carries the soft grain of uncertainty. It is not a flaw, it is the openness that lets later facts land without drama. The file is not a verdict, it is a record that trusts the next page. Assumptions when stated are modest. If the nucleus is sealed under a crust baked by long travel activity may wait until heating is intense. If vents open along stress lines, jets may appear and fade without pattern. If dust sheds, the coma may swell in an uneven veil that complicates photometry. If the surface is smoother than expected, reflection may carry a specular shine for short angles. Each if is small and useful. Collectively, they set a field where prediction can walk carefully. The habit here is to leave room for what is not yet seen and to do so in terms that encourage sleep rather than alarm. Teams that write software shape their tools to the case at hand. Orbit solvers accept the possibility of non-gravitational terms that stand for the push of gas and dust. Light curve fitters allow for rotational harmonics that might be masked by geometry. Spectral reducers script branches for solar contamination near conjunction where the sun's own lines can lean across the object's light.
Thermal expansion
Clock audits
sends
multiply.
fine, silent tremors
Observatories
across
check against
fissures
global
on
time
Atlas,
standards
and
and
the
then check
lines
again
settle
against
again
neighbors.
as heat diffuses
The aim
inward.
is simple, to make it very easy to believe the ordinary and straightforward to recognize the rare. There is a philosophical stillness in this stage. Definitions are balanced on practicality. The community agrees without needing to say it that labels trail facts. When facts move, labels will follow without pride. That humility feels like a soft mattress under the whole enterprise. It allows models to be written clearly and held lightly. It keeps the conversation hospitable when the unexpected arrives. It gives everyone a way to remain calm in front of the star that governs the next chapters of this study. As conjunction approaches, the file gains a second rhythm tied to instruments that can see near the sun. Coronagraphs that hide the bright disk prepare sequences with care. Spacecraft that measure the wind and the field-tuned sampling rates to catch small disturbances that sometimes accompany dusty bodies. Planners rehearse the handoffs that carry a target from night skies to solar instruments and back again. The cadence tightens, but the tone does not. It remains the tone of steady work carried out by people who like careful detail and who trust that detail to carry meaning. The story of context includes the public, though only at the edges. A few observatories share quiet notes that a rare visitor is inbound. Articles in general outlets collect the outline without strain, explaining that some objects come from beyond and pass through without lingering. The explanation is not a promise of spectacle, it is an invitation to be patient alongside the professionals who do this for a living. Some students find the ephemeris and pencil the line into notebooks. Some teachers place a pin on a classroom map. A small, wholesome attention surrounds a point of light none of them can yet see. Within the professional record, the first simple plots stabilize. Brightness against time climbs at the slope expected for an object of this likely size and reflectivity. Color indices sit in a narrow corridor that matches a surface that has worked against the slow abrasion of interstellar dust. No coma rises beyond a faint blur that can be argued away as seeing. If there is outgassing, it waits for heat. If there is structure, it hides inside a blur small enough to be a single point, even to a fleet mirror above the air. Expectation holds. Calm holds. The file holds open. Every plan that follows rests on this unhurried foundation. The point continues inward. The sun grows larger in the context of the work, not as an image, but as a set of conditions moving from mild to intense. The next pages will feature models of how the light should crest and fall, how heat should rise and soften, how spectra should scatter and glow, how a path should bend a little under the push of gas. The dossier does not predict wonder. It predicts behavior that makes sense. That is enough for now. The quiet of being prepared is its own form of comfort. Conjunction approaches like a tide at dawn, not sudden but certain as the inbound point moves toward the sun's glare along a line that instruments know well. Schedules tighten by quiet degrees. Coronagraphs that will shield the solar disk are checked against star fields. Spacecraft roll plans are rehearsed so that panels and antennae keep safe angles while cameras look as close to the light as engineering allows. Ground observatories accept their pause with good grace, handing the record to platforms in orbit that were built to dwell in brightness. Nothing dramatic is said. The work narrows to essentials, and the sky reduces to a small annulus where information can still be kept. Geometry becomes the narrator. From Earth, the object sinks into morning brightness, lower each day, until even long exposures find only wash. From space instruments that hide the sun behind an artificial eclipse begin to see the region where a traveler might appear as a moving spark. Predictive ephemerides converge on narrow corridors and pointing scripts align those corridors with detector margins so that one field flows into the next without gaps. If the point keeps its pace, it will cross a wedge of view at a known angle and at a time stated to the second. If it deviates, the deviation will be measured against this orderly frame. Timekeeping receives new emphasis. Atomic standards distribute moments through the deep space network, and observatories align their shutters to those seconds so that every frame can inhabit the same timeline. Light travel is accounted for in both directions, from sun to object to sensor, and from spacecraft down a radio beam to a ground station whose own location on a turning Earth is known to fine detail. The cadence that begins as clicks in machine rooms becomes a net of agreement spread across the inner system. In that agreement is the calm promise that later, when questions arise, the record will be able to answer in full sentences. Conjunction does what conjunction always does. It takes the sky away from ground-based watchers and gives it back to instruments made for proximity. The European Space Agency's Solar Orbiter, the long-working Solar and Heliospheric Observatory, and the Parker Solar Probe extend their attention across the brightness. They are not built for comets alone, but for the weather of the star itself, and yet their fields are generous enough to welcome any small drama that threads the corona. Teams prepare to arch the record from night telescopes to solar instruments and back again so that the story of motion will not have a seam. The first days within glare are mostly quiet. A few pixels shift in ways that look promising and then resolve as cosmic rays or coincidence. Analysts lean on the discipline of not believing too quickly. Background models are updated to subtract the delicate grainy light of the corona. A suspected trace appears at one edge of a frame and fails to appear in the next where motion would have carried it. Another trace does the opposite. The object remains unconfirmed until a string of detections lines up with the narrow path that ephemerides had written in advance. Patience keeps the line clean. The silence is procedural rather than ominous. The signal remains compact. Even near the sun, there is little in the way of a diffuse stress of dust. The dot moves at the pace predicted by energy and geometry, neither rushed nor languid, and for a while the record is beautiful in its ordinariness. Brightness rises as phase favors the forward face and then steadies. The shape of the curve is as expected for a modest body passing into stronger light. Thermal models, still assumptions written in marginal notes, predict a smooth climb that will later soften after closest approach. Nothing requires revision, nothing leans against expectation. There is a gentle strain to working near the sun. Detectors saturate if a bright loop of plasma flares at the wrong time. Scattered light crawls where nothing should be. The corona itself moves slow and seething, and subtraction must be careful not to erase what is not yet known. Teams rotate through shifts that match spacecraft passes and downlink windows. A camera rides behind a circular mask that makes an artificial night around a disk of day, and somewhere inside that ring a small point crosses a grain of brightness. People who have done this often keep their voices steady and make notes that are short and clear. Beyond pictures, other instruments listen. Magnetometers watch for small ripples in the field where dust and charged particles may meet. Particle counters note the slow weather of the wind that streams outward from the sun. Radio receivers ride along in survey modes that accept the possibility that a body moving through dense light might scatter signal in subtle ways. None of these readings seek spectacle. They seek pattern, because pattern is the way the star and its visitors reveal their conversation. For the moment, the conversation is polite and unremarkable. The object reaches the limit of ground visibility and slips fully into the care of solar instruments. Public channels remain spare and factual. A note confirms detection in a coronagraph sequence. Another lists expected hours for the window around closest approach. None of the messages are dramatic in tone. They are coordinates and times and gentle reminders that the effort is collaborative by design. Amateur communities follow the updates and wait for post-processed frames that will be shared once the event has passed. The quiet outside the control rooms matches the quiet inside them. Closest approach approaches and the tempo does not change. Checklists steady the hands that move sequences forward. Exposure times step down to avoid the sun's stray brightness. Binning strategies are tuned so that a faint core is not smeared by the need to save bandwidth. Clock audits proceed even during the event because timing is not an ornament but the backbone of any later reconstruction. If a curve bends unexpectedly, the knowledge of when will matter as much as the knowledge of how much. The habit of measured attention is a kind of shelter under which uncertainty can arrive without causing harm. There are brief moments when the corona brightens along a streamer and threatens to hide the track. There are brief moments when a quiet lane opens between plumes and the point walks across it with unexpected clarity. These small mercies are welcome not because they promise drama, but because they tighten error bars and leave less room for doubt. A sequence captured cleanly across such a lane can anchor many others that are noisier. Later, when the story is stitched, the quiet stretches will be the strongest thread. Through all of this, the tone remains calm. The observatories do what they were built to do. The object continues on the track that first placed it in these fields of view. The atmosphere of the story is not suspense but attentiveness, a shared agreement to let the sky show itself without urging. Conjunction is a known passage. It takes away some eyes and gives other eyes their moment. When the path carries the traveler back into ordinary night telescopes on Earth, we'll take up the thread again. Until that handoff, the watch proceeds with the soft confidence of well-prepared plans. In this calm, the day of perihelion arrives. It is a point in a calculation and a gloss of light in a moving picture. The object is where the numbers said it would be, and the record is ready to hold what happens without haste. Whatever the hours bring, they will land first on a well-made net. That certainty is not excitement, but it is a kind of quiet joy, and it frames the threshold the story is about to cross. On the morning of closest approach, the effort is already in motion, a soft choreography that began weeks earlier and now holds its shape without strain. Perihelion, the moment of nearest distance to the sun, is written into every schedule and every mind. It is both a point in a model and a span of hours in which light, heat, and motion can teach more than months of quiet travel. Networks coordinate like a tide that knows its shoreline. Ground observatories yield to shields and masks in space. Consoles show simple status lines in calm fonts. The feeling in rooms and on mountaintops is not tense, it is attentive. Expectations are precise but not brittle. Simulations that combine rotation, reflectivity, and phase angle draw a smooth crest in brightness that should rise round and fall with the ease of a well-behaved comet. The team that tends thermal models expects a modest surface to warm in a gentle curve, to lag slightly after the peak, and to cool as the object reclines into wider space. Spectral plans anticipate the familiar signatures that wake near the sun. Water broken by sunlight should leave hydroxyl lines. Carbon should show its simple molecules. Dust should scatter light with a grain that looks like 1,000 earlier Comey. The value of prediction here is not certainty, but contrast a frame against which truth can be seen. The people who keep clocks treat time as a material. Observatory shutters tick against the standard that the Deep Space Network shares across oceans. Telemetry frames carry their own stamps embedded as plainly as an address. When a camera looks and when a radio antenna listens, those moments are placed on the same thread so that later the weave will hold. It is a habit that appears nearly invisible and yet underlies every conclusion. If there is only one quiet hero in this kind of work, it is agreement about when. Instrumentation leans towards safety and clarity. Coronagraphs adjust exposure ladders to avoid overflowing on a bright streamer. Detectors are cooled to steady their noise. Spacecraft orientations are chosen to keep heat away from edges that would protest. Ground telescopes, setting aside for a little while, perform dark runs to keep their systems ready for the return. The poetry here is simple. Everything that can help a small signal survive in a large light is done. Everything that might introduce a surprise that is not from the sky is softened or deferred. Ephemerides refine with each confirmation. The path through the annulus of view is plotted to fine angles, and small allowances are held for solar weather that moves like slow surf. When plumes in the corona drift, subtraction is adapted carefully so that the sky is not erased along with the sun. Analysts who have practiced this kind of balance for years keep their notes brief and factual. A small moving point enters one edge of a frame as predicted. It crosses at a speed written days ago in a circular that any observatory could read. The confidence that follows is quiet and shared. In the hours around the moment, shifts overlap. Fresh eyes relieve steady ones. Hot drinks go cold beside keyboards and consoles. Air vents hum. The world outside these rooms and domes carries on without knowing that for a short span, the line between expectation and discovery narrows to the width of a star's halo. The object does not know that either. It keeps to gravity and sunlight and whatever else, if anything else, it carries within. The watch is human, not cosmic, and that scale difference brings a calm humility to every keystroke. Pictures arrive first. A sequence shows the object gaining and holding brightness in the context of glare. The core remains tight, the surrounding light soft rather than ragged. Another instrument tuned to heat returns curves that begin to rise with the steady ease of a simple surface greeting more energy.
The
A
ion-tail of
spectrograph
Atlas
lays down a thin ridge where water and carbon often speak. The record thickens. Planners breathe in a measured way because this is what should happen. The comfort of being right is not pride. It is the sense that the world is behaving in a language already learned. Not every frame is clean. A streamer intrudes. A jitter in a reaction wheel adds a shallow smear to a line that would have been straight. A burst from the sun lays a haze across an otherwise kind image. None of it matters much because redundancy is the quiet architecture of the effort. A second camera overlaps. A third pass catches what the first missed. Later, the repairs will be invisible because the fabric is woven from many threads, and strength here is less about any one strand than about the number of crossings. Away from images, instruments that taste the wind continue their own quiet work. The magnetic field near the object's path stirs in ways that match the general weather of the day. Particle counters report a flux that keeps within the broad ordinary range. If a body is shedding, if dust is flying, if gas is giving itself to space, the signs are not yet bold. That too is a kind of lesson. Not every traveler breathes loudly near the sun. Some keep their own counsel until the angle of light and the condition of surface cross a threshold that no one can calculate in advance. When the approach crosses into the exact minutes and then the exact second nothing breaks the tone, the camera field remains set. The calibration lamps and dark cycles hold their place in the schedule as if this were any other night, because discipline that changes shape for drama is not discipline at all. Perihelion is a point on a curve that assumes smoothness. If the curve remains smooth, the record will be simple to read. If the curve bends, the record will let it be seen. Either outcome is an answer worth having. Messages cross the network with the spare language of teams that know each other well. A confirmation of passage appears in internal logs. A short public note follows with a time, a field, and a remark that observations were successful. The restraint is not secrecy, it is the culture of letting analysis speak before adjectives. Within laboratories and control rooms, people step back from desks and stretch. There is satisfaction in work done as planned, in instruments that behaved, in the sense that a rare event has taken a position in the ledger of the sky, written clearly. The vigil does not end at the peak. The outbound arc begins immediately and attention follows it without a seam. The models continue to offer their curves for comparison. The sky continues to provide the raw material that those curves will meet. Ground telescopes prepare to take the thread again as the glare loosens. Cloud forecasts are read in the same careful tone as solar bulletins. The handoff from one domain to another is part of the beauty of this discipline, a relay not of excitement but of care. As the hours lean away from the moment, a small awareness grows, nothing sharp, more like a pressure just beneath thought. A few points on early plots sit a little outside their lanes. A line that should be smooth has the faintest ripple. No one writes meaning into it yet. The proper order is to finish the watch, to gather every frame, to check the clocks once more, to return a discipline of rest to the instruments that held steady in bright weather. The story has crossed a threshold. It has done so with the calm of good practice. Whatever lives in the data will come next, and it will be read in the same quiet key. The first strangeness arrives as light. Photometry, usually the most obedient part of a comet's story, pauses and raises a quiet hand. The curve that should rise cleanly to a single crest near closest approach, then settle into a soft decline, develops a rhythm instead. A short sequence of peaks stands out from the background, like notes tested on a quiet instrument. The change is small at first, then sure. Analysts trained to distrust charm do not name the pattern. They widen the aperture, revisit sky subtraction, and let the process of ruling out the ordinary act as a lullaby against haste. A light curve is a simple idea written with rigor. It is brightness against time, corrected for the angle of sunlight and for the changing distance between observer and object. On this morning, the corrections are exemplary. Clocks are aligned to shared standards. Flat fields and dark frames are recent and clean. The corona's grain close to the sun is modeled and removed with the care of a restorer working at the edge of fresh paint. The remaining points should flow into a single smooth swell. Instead, they step upward, pause, and step again. 3 distinct bright intervals take shape. The first rises earlier than the peak predicted by models of rotation and phase. The second crowns almost exactly at perihelion, as if the forecast were respected for one beat. The third, most curious of all, arrives late at a time when the object should be dimming into outbound light. In each case, the change is brief and coherent. The crest lifts by a little more than a tenth above the drift of the larger curve, then falls away. Between these crests are hollows that touch nearly the pre-event level, as though a shutter passed across a lamp. The instinct to doubt is healthy and immediate. Solar glare can deceive. Stray plumes in the corona can lend false pattern. Instruments can ring when heat or field and structure meet in unhelpful ways. Teams answer those suspects in turn. Independent reductions use different background models and still recover the steps. Separate instruments with separate histories show the same timing. A camera mounted on a spacecraft millions of kilometers from Earth records the same cadence as a telescope high in the Chilean desert. An observatory in the Canary Islands and another in Hawaii, seeing different air and different sea, report the same rises and rests. Timing becomes the keystone. The crests are spaced by intervals that sit just under 1 hour, steady enough to feel imposed rather than found. The scatter within those intervals is small, well within the combined uncertainty of clocks and light travel corrections. Analysts place the 3 crests against the exact minute of closest approach, and the alignment is uncannily tidy. Before, at, after. If glare or weather were making mischief, the agreements would drift. They do not. Each data set, when laid against the others, hums on the same beat. Polar angle and phase do not rescue the ordinary explanation. As the object moves through geometry that changes the way sunlight skims the surface, the rhythm persists. A model that assigns the effect to a bright cap or stripe that comes into view as the body turns would smear the peaks as the angle shifts. The steps remain crisp. Faceting an imagined flat plane that could flash a specular glint would steepen only one side of each peak and leave the rest of the curve unmarked. Here the rises and falls are symmetric and repeat. With the pattern established, hypotheses gather in a respectful circle around the data. Jetting is the conservative thought. If vents opened and closed in a brief sequence, dust and gas could lift reflectivity for moments at a time. Yet ordinary jets complicate rotation. They tug, they flicker with sunlight, they fray at the edges. The light here is disciplined, the background steady, the peaks narrow and evenly spaced. Another line of thought returns to rotation itself. A small shift in spin rate aligned with the crests could in principle swing a reflective sector into view and out again. The amplitudes, however, suggest something more than paint on a turning stone. They imply coherence over a surface large enough to speak in unison. Cross-checks reach for every modest trick the field knows. Observers test for color change across the peaks. If dust drove the bright moments, some reddening or bluing might accompany the change. Color remains largely flat within the limits of the instruments and the glare. Apertures are widened and narrowed to check whether a faint coma swells and shrinks in step. The answer is no within the noise allowed by the solar background. Photometric zero points are re-derived from field stars to make sure a drifting calibration is not writing its own music into the line. The points return to the same rhythm. In the control rooms, the tone does not rise. The words that appear in internal notes are restrained and exact. Luminosity modulation observed. Intervals consistent within stated tolerances. Cross-platform agreement. The restraint is not a denial of wonder, but a way of keeping wonder company without startling it away. A few older hands recall other curves that misled for a night and then settled. A few younger ones stand a little closer to their monitors. The culture here treats both kinds of attention with equal gentleness. As the second crest passes through the minute of nearest distance, the third begins to be the subject of quiet expectation. If it fails to arrive, the story will bend toward an explanation anchored in transient geometry. If it arrives, the pattern will take on the weight of intent without using that word. The minutes pass and the background holds. Instruments that were not built for comets, tuned to watch the sun, render their small guest with more fidelity than anyone had a right to expect. The third rise lifts cleanly and then declines with the same delicacy as the first two. By now, enough independent lines have converged to make the effect part of the record rather than a footnote. The amplitude is modest but repeats. The spacing is steady. The phase of the crests with respect to the path of closest approach is poised with surprising grace. Nothing in this paragraph explains the cause. Everything in it underlines that the phenomenon is real within the limits of methods built to be sober. Interpretation stretches gently. A surface with variable reflectivity could be reorienting in response to heat opening or closing fields of bright texture. A shallow snowfall of grains could be organized by electric charges into an ephemeral skin that changes how light scatters. Something internal could be distributing energy through a crust, moving brightness around like a slow wave on a pond. Each thought remains a sketch against a wall of caution. None needs to be true for the next steps of the study to proceed. All that is required is the acceptance that a traveler from far away has answered the sun with a rhythm no one forecast. The day closes with the curve archived in many places. The points that lift and settle are now part of a shared memory among instruments that do not know one another except through the people who tend them. The cadence glows faintly on screens, a sequence that fits inside a single hour and yet expands the field of possibility by a good calm margin. The watch continues because the hours after Perihelion have their own lessons and because light is only one way an object can speak when it passes near a star. Heat follows light as the next voice in the record. Instruments tuned to the long glow beyond red begin returning curves that in ordinary cases draw a smooth hill across the hours around closest approach. The expectation is simple. Sunlight meets surface. Temperature rises, lingers, and eases. Instead, the lines waver in a pattern that echoes the brightness steps already noted. Where the light lifted and settled, the heat does the same, not in a haze of noise, but in pulses spaced with a steadiness that invites careful attention. The effect is modest then firm, and it holds across platforms that observe from different orbits and lines of sight. Infrared sensors on spacecraft treat the object as a small ember moving through a bright furnace. Their detectors, cooled and guarded against stray light, measure the way the ember warms and radiates. The readings rise, fall, and rise again within a span just under 1 hour, then repeat once more even after the point of closest distance has passed. The cadence is not sharp like a switch. It moves with rounded shoulders as if heat were being gathered and released by a process that prefers grace to edges. Analysts verify that the rhythm is not an artifact of background subtraction near the sun. Independent reductions recover the same undulation. The geometry of heating should be the simplest part of the perihelion story. The face that sees the sun warms, the face turned away cools. The temperature on both sides changes at a pace set by the ability of the surface to conduct and store energy. Here the map seems to shift under the instruments. A hemisphere that should brighten steadily shows a brief softening, while the opposite side grows warm, as though heat migrates across rather than sinks downward. The delay between gaining light and gaining warmth compresses to minutes rather than hours. Thermal inertia appears small where distance suggests it should be large. On a noisier day, such differences might disappear into the margin. On this day, they remain. Ultraviolet eyes add a thin thread to the picture. A spectrograph that watches the sun's near environment notes short, narrow bursts along wavelengths that often accompany ionized metals. The bursts are faint and brief, appearing near the trailing edge as the object rounds its path and then fades from that band. The association is tentative. The sun's own lines are a crowded field, yet the timing of these small flashes sits close to the thermal pulses, and the repetition over several cycles invites the observation to remain in the file while stronger explanations gather. A second surprise arrives in the direction of maximum heat. Instead of pointing straight toward the sun as a simple model would demand, the hottest region lies a small angle aside, and the angle holds steady through the sequence. That offset aligns with the vector along which earlier analyses traced a narrow pattern in the dust, a poetic coincidence that may be nothing or may be a thread. If jets are involved, they would normally bring irregularity. Here the heat seems organized around a stable geometry like a compass that knows true and holds to it while the ship turns. The texture of the thermal curve matters as much as its peaks. The rises are quick but not abrupt, the falls gentle and measured, and the baseline between them does not show the steady climb one would expect, as the whole body
Near
absorbs
conjunction,
more light.
the solar background
Instead, the floor of the curve
softens
breathes
the
up a little,
contrast
down a
around
little,
Atlas,
as though
while
part of the
its steady
surface is
motion
being shaded or
continues
polished
unbroken.
by a process that does not leave dust in its wake. The absence of a swelled coma in the images that accompany these readings strengthens the sense that the changes live at or below the skin, rather than in clouds around the object. Spectral windows in the near-infrared narrow and delicate register hints of molecules that form when carbon meets heat in certain metals. Nothing loud, nothing that would cure doubt in a single glance, but enough to keep instruments pointed and to justify the quiet persistence of observers who prefer to let patterns announce themselves over time. If a skin contains patches with unusual emissivity capable of shedding or keeping heat with more control than rough rock and dust that could mimic the observed behavior without asking for grand mechanisms. If grains charged by the solar wind organize into a temporary layer, that too could change how warmth leaves the surface. The Parker Solar Probe listens with its own set of senses. Magnetometers sensitive to the small signatures that ripple when hot material meets field log, gentle perturbations that crest and ease on a schedule similar to the thermal steps. Particle instruments tuned to the background weather of charged streams note slight changes that coincide with the pulses but do not swell into anything like a storm. These data are soft and prone to drifting interpretations. They sit in the folder labeled context, where they add atmosphere rather than verdict. Across facilities, efforts to falsify the pattern continue as a matter of culture. Analysts test whether the infrared detectors show the same cadence in empty regions of the corona on either side of the track, a guard against rhythmic noise masquerading as signal. They ask the models to imagine a bright streamer sliding under the aperture at just the right time to mimic a pulse. The subtraction refuses that plot. They recheck clocks because time is the place where clear stories sometimes blur. The stamps agree to within margins that leave the rhythm intact. Speculation, when it arrives, comes softly and with definitions. Controlled heat does not have to mean control by intention. A layered surface can in principle act like a managed system, even if made by natural processes, especially under sudden heating. A crust that opens and recloses along regular stress lines could ferry warmth side to side in ways that look like governance. Volatile pockets that melt and refreeze could exchange energy rapidly through thin channels, creating the appearance of circulation. Even in this gentlest frame, the synchronization with the light pulses lingers as an open question. If two independent systems sing the same tune, either a hidden conductor is at work, or a single mechanism plays two instruments. The temperature record continues beyond the ideal peak. The third pulse, which lights later than the simple model, arrives again in warmth. This time it comes from a region that the viewing geometry keeps close to shadow, suggesting emission rather than reflection. The distinction matters to interpretation and feeds the conservative line of thought that favors a skin with changing properties over an external display of dust and gas. A surface that can alter its emissivity under stress would behave in just such a way, brightening thermally where it reflects least. By the end of the sequence, the file holds a harmony between light and heat, each rising and falling in step, each offset by small consistent angles in space and time, each refusing to be absorbed into ordinary models without leaving ragged edges. The tone among teams remains untroubled. Curiosity is the only heat in the rooms where these plots are drawn. The words that enter the shared notes are cautious and calm. Thermal modulation observed. Phase and amplitude cohere across instruments. Direction of maximum emission offset by a fixed small angle. The pattern is not a conclusion. It is an invitation to consider how surfaces, fields, and light can conspire to produce rhythm. What rests on screens at shift's end is simple to look at and complex to explain. A traveler from far away meets intense sunlight and answers with warmth that moves. The pulses carry the story forward without forcing it, laying a path toward jets, toward structure, toward chemistry, and toward the old possibility that something like intention can be made of physics alone. The watch continues into the realm of material, leaving the surface where shape and flow may confess what heat and light have only suggested. With light and heat already speaking in rhythm, attention turns to the material that leaves the surface. In ordinary cases, gas and dust lift from weak spots and spread into fans that flutter with rotation. Here, the first clear frames within the coronagraph fields show something more deliberate in shape. From the compact glow around the nucleus, narrow columns rise and hold their lines for minutes at a time. They do not feather into wide veils. They keep to angles that barely wander, as if drawn with a steady hand through moving brightness. The columns are few, not many, and they repeat from the same regions over the span of several cycles. The Solar and Heliospheric Observatory supplies long sequences where the star is masked and the near environment glows. In those sequences, the jets emerge as thin, pale strokes. The European Space Agency's solar orbiter refines the view with a different geometry and confirms the same narrowness. A ground-based sequence taken just before the object sinks into daylight and just after it returns shows the same orientations within the uncertainty that glare permits. Each instrument brings its own bias and noise. Each is reduced by different hands. All recover a pattern that prefers straightness and consistency over drama. When deconvolution is applied to the inner coma, three primary outflows become clear. They are spaced as if points on a circle were chosen with a compass. The angles between them hover near equality, as though separated by thirds of a turn. The columns do not precess freely with rotation. Instead, they keep a fixed relation to an axis that the photometric record has already implied. When the body turns, the trio turns with it coming into and out of view in a cadence that marks the same interval just under 1 hour that brightness and warmth have traced. The harmony among these distinct measures begins to feel like structure rather than coincidence. Natural jets, when steady, still tend to splay with distance as molecules collide and dust spreads. In these frames, the columns keep tight, their cross-sections barely widening until they fall below detection in the glare. The degree of collimation invites explanations that involve charges and fields. Near the sun, photoionization acts quickly. Grains and molecules leave the surface and meet light that frees electrons, leaving residues that feel electric forces. The background magnetic field shaped by the solar wind can guide charged material into filaments. Yet the stability of the angles across hours suggests a source that holds its aim as the wind itself shifts. A surface vent alone can explain position, but not this persistent straightness unless the material is tuned to the field that receives it. Spectral slices add a soft tint to this geometry. Along one column, the signatures of carbon monoxide rise a little above the others. Along the second, a faint band near the lines usually associated with molecular oxygen comes and goes with the same rhythm as the pulses in brightness. Along the third, a whisper of heavier atoms metals, rarely seen in such clear isolation, touches the record at moments that match the thermal peaks already described. None of these strands is loud enough to claim a discovery by itself. Together they suggest that each column may not only be a direction, but also a character, as if different sublayers are venting through separate throats. Dynamics find their cue in this drawing of lines. Non-gravitational terms in the orbit fitters, initially set as placeholders for the modest push of gas, begin to cohere into a vector that points not randomly, but in relation to the trio. The net acceleration remains small, well below anything a casual eye could see on a screen. Over hours, it nevertheless nudges the path in ways that careful astrometry can feel. The direction of that nudge lies between the columns, as though the three together are arranged to cancel torque while leaving a gentle thrust. The rotation rate watched closely because jets often induce wobble steadies within narrow bounds, and even rises by a breath, a change consistent with a geometry that adds spin rather than subtracts it. Models submit their first sketches, place 3 vents near an equatorial band separated by equal longitudes, and they will act like a stabilization system. Align their averages a little off the sun so that the net force leans gently along the outbound track, and the result is a slow, steady push that leaves orientation largely unharmed. Such a configuration does not have to be made by intention to behave like intention. Stress fields can fracture in repeating patterns. Fracture can favor planes locked to the way a body cooled and turned through long years. Still, the neatness here feels unusual. Most comets exhibit mess. This one draws a triangle and holds it through heat. The texture of the column speaks for confinement not only in angle but also in density. Their interiors remain brighter than their edges, as if the flow stays organized rather than diffusing immediately into the corona. Electrostatic charging of dust can in principle keep grains within narrow corridors for short distances. Magnetic interaction with ionized
Thermal
gases can do the same,
sends
though usually with wavering
silent
edges that
tremors
answer to
across
the shifting
fissures on
wind.
Atlas.
The
And
lines here
settle
barely shiver.
again as heat
The impression is of a
diffuses
mechanism
inward.
that smooths feedback like a damper in a system that must operate in noisy weather. That image is metaphor, not assertion, yet it sits comfortably beside the data. Independent telescopes that look from the night side add context once glare loosens. Adaptive optics on large mirrors render the inner coma as looping strands that, when folded back through deblurring algorithms, map onto the same 3 directions traced within the chronographs. Polarization measurements sensitive to the way light scatters from particles return values that imply a mix of sizes and perhaps smoother grains than usual. The combination supports an interpretation where dust does leave the surface, but does so in organized bundles rather than as a broad cloud. The bundles carry a mixture whose optical behavior could explain the calm mirror-like flashes that ride the earlier light curve. Across the sequence, the moment when each column brightens and when it subsides remains in step with the pulses in brightness and heat. The alignment is close enough that if the 3 curves are laid atop one another with time, as the common axis, their crests form a shallow braid with only small separations. Such concordance tempts bold language. The discipline that guides this effort prefers gentler phrasing. Coherent multimodal modulation is the term that enters the notes. It means that different ways of seeing agree upon a schedule without naming what keeps the time. Dust-tails often remember history in their striations, the way past ejections braid into thin parallel limbs. In the days after closest approach, when the object moves outward and the sun's blaze yields to starry sky, those limbs appear with beads spaced like the earlier pulses. The beads do not prove cause, they record rhythm. The pattern fades as distance grows and the tail relaxes into a more familiar fan. Still for a little while, the geometry is a visible handwriting on space written slowly by leaves of dust that keep their places long enough to be read. The community remains in its quiet key. Words like unusual and sustained join the shared vocabulary, but they rest alongside terms that are more domestic to this field, such as jet morphology and coma structure and non-gravitational drift. What sits at the center is not a verdict, but a drawing made by the object itself. a triangle that holds while light and warmth rise and fall. If jets alone can do this, then nature has found a graceful answer to the sun. If something more than vents participates, the data will continue to invite a careful imagination. Either way, the lines are beautiful to follow, and they carry the story onward toward time where another kind of geometry waits. Timekeeping is the quiet spine of the campaign. Every exposure, every radio frame, every thermal sample lives by a stamp that says exactly when a shutter opened or a sensor read. Atomic standards at deep space dishes keep cadence with clocks that drift less in a year than a human pulse slips between breaths. Light travel is corrected with the care of a navigator drawing small triangles across a chart. When a record like this is later stitched, the seams vanish because all the threads agree on the hour and the second. In such order, anomalies stand out not as noise but as tone. Around the hours of closest approach, the tone changes. Perihelion, a single moment defined by geometry, refuses to sit on the same tick in every ledger. One agency's coronagraph marks the instant at a time that should anchor the rest. Another instrument, watching from a different orbit, places it a small number of minutes later, and a third system adds a minute more. The differences do not obey simple distance. After standard light time corrections, the gaps remain, as if each instrument saw the same event shifted gently along a ruler of its own. The surprise is not that small offsets exist. The surprise is that they scale with the pulses already seen in light and heat. Analysts treat clocks with suspicion first. Ground stations are checked against the network, then against each other, then against their own local oscillators. Logs are searched for any brief loss of lock that might have slid a second sideways. None appears. Onboard timekeeping is examined next. Spacecraft carry their own clocks and apply their own corrections when they compress and transmit data. If a packet were stamped late, it would carry an echo of that error. When raw frames are pulled from storage and compared with unprocessed telemetry, the stamps agree within the narrow bounds that these systems promise. Pipelines are exonerated step by step. The minutes remain. Geometry is asked to speak again. Light from a moving object reaches different observers at different times. Those delays are well constrained and are the first correction any timing analysis applies. Here they have been applied. The residual offsets vary not with changing distance but with the rhythm of the object itself. During each bright crest, one platform leads. During each hollow, another does. The order repeats across cycles as if the pulses borrow a little time from one instrument and return it to another in the next breath. The pattern is small, but small is not the same as negligible when the record is this clean. Solar weather offers a conservative path. The corona is a sea of charged particles and fields. Variations in density can slow a radio wave or bend a path of light by amounts that appear as micro-delays. If such delays were the culprit, they would correlate with the structure already mapped along the line of sight. Analysts fold in synoptic images and models of coronal density, searching for features that could swing variance in step with the cadence. The parallels do not hold. The corona shifts on scales of many minutes and many thousands of kilometers. The offsets sit on the gentler drumbeat already written into the object's own behavior. Instrument thresholds are considered. Some cameras adjust exposure or gain when a target brightens sharply. If the pulses triggered such behavior, the exact center of an exposure might drift. That would be a prosaic answer. Engineers review configuration files and housekeeping data. Auto settings are off where they matter, fixed by plan for the perihelion pass. Exposure start and stop times recorded with precision show no synchronized drift that could mimic a moving moment. The cameras looked when they were told, and they wrote down when they did so. The minutes do not come from habit hidden in electronics. A different thread enters from magnetometers and plasma sensors. On a spacecraft that listens to the solar wind, a small rise in field strength appears a handful of minutes before a bright pulse is visible to a coronagraph peering nearby. On another platform, the relative order is reversed. These are not definitive clues. Fields are notorious for their local politics. Yet when phase analysis is applied, the timing offsets between instruments line up with the same gentle frequency that runs through light, heat, and jets. Not all cycles match in detail. Enough do to make the correspondence a feature rather than an anecdote. Teams try to lock the timelines by anchoring them to a shared event outside the object itself. A mild flare ripples across the sun during the sequence. Its onset is a sharp marker present in both optical and radio channels. When the records are pinned to that common moment, the offsets around the object persist. Cross-correlation in the frequency domain finds sidebands that sit at a small fraction of a cycle per minute, the same fraction seen in the brightness record. The mathematics does not give cause. It confirms only that time here behaves like another channel of the signal. Consequences reach into orbit fitting. A shift of even a single second matters when speed is measured in dozens of kilometers each second, and when geometry magnifies small projections into large differences tomorrow. Predictive ephemerides are recomputed with care taken to isolate assumptions. Without the pulses, the outbound path sits on one line. With the time offsets kept as observed, the line bends by a small and measurable amount. Over the hours following the pass, the bend amounts to several thousand kilometers of lateral drift. That is a number that sounds large to the ear and modest to the sky. It is big enough, however, to shift the pattern that ground telescopes should expect when the object re-enters the night. Language stays careful. No one says the time itself misbehaved. The notes say that measurements disagree in ways that correlate with a physical cadence. That statement is precise and small. It leaves room for explanations that live inside the instruments, inside the environment, or inside the physics of the object without claiming any of them. Terms like temporal phase offset and synchronization bias enter slides and memos, not to obscure but to keep the field clean of words that would wander beyond evidence. Some thoughts bend toward lensing the way gravity can delay and deflect light that grazes a massive body. The sun does this always. Its effect is part of every correction applied to these data. For an additional lens to exist near the object mass would have to be present in a way that other clues do not support. The idea passes through the room and is set aside without prejudice. Other thoughts ask whether a skin of ionized gas around the traveler could behave like a changing mirror for light and a changing path for radio, imposing a rhythm on the arrival of photons. That line remains open. It does not yet rise to an explanation. By the close of the analysis day, time feels less like a background and more like a participant. The sequence of pulses has found a way to leave small signatures not only in light and heat and outflow, but also in the agreement among clocks that rarely disagree. The effect is not dramatic. It is a quiet fold in a fabric that is usually flat. In a campaign tuned for sleep, even this fold is described peacefully. The record is amended with care. The timelines are shared in versions that carry both the original stamps and the aligned frames. Later work will decide which is the better anchor. What remains is a gentle recognition. A visitor from far away moves through brightness with a rhythm that touches more than one sense. It touches light, it touches warmth, it touches the shape of the material that leaves. It brushes against the way instruments decide when now has happened. The story keeps its calm because calm is how true patterns are kept intact long enough to be understood. The clocks keep their beat. The object keeps its own. Between them, a small, steady dissonance hums and invites patience. Spectroscopy, the art of spreading light into its threads, usually turns confusion into order. In the hours around closest approach and in the nights that follow, instruments on high mountains and in steady orbits divide the glow around 3Y Atlas into fine color and pattern. The expectation is familiar. Ice should break and show the fingerprints of water altered by sunlight. Carbon families should sketch their bands. Dust should scatter with a texture that says what size its grains prefer to be. The first passes return those comforts, soft ridges where they belong, quiet troughs where they are expected. Then gently other lines lift from the baseline, narrow and persistent enough to hold the eye without raising the voice. Ground telescopes with large mirrors and cold spectrographs record faint features near the edges of the visible and in the near infrared. The European Southern Observatory's great mirrors in the southern desert contribute long patient exposures under dry air. A northern facility on an island in the Atlantic adds its own long stares between dawns. A spacecraft spectrograph that watches the sun's neighborhood tuned more for plasma than for comets captures short sequences with a different bias. None of these devices was built to match the others, and that is part of the strength. Where they agree, the agreement carries the weight of different paths to the same place. Analysts begin with subtraction. The sun injects its own bright handwriting into every spectrum taken near conjunction. That script must be modeled and removed carefully so that what remains can be trusted to belong to the traveler rather than to the star that lights it. Scattered light from the corona is treated the same way as a gentle haze laid across the page. When those layers are peeled back, narrow lines appear where broader bands are usually the rule, a trio of delicate peaks near wavelengths that metals sometimes claim rise above the noise. They are not loud, they are regular. Their spacing and relative strength echo across instruments that do not share detectors or optics. The conservative answer is contamination. Spectrographs are sensitive instruments that live in real rooms under real domes and within real spacecraft. A faint reflection from a calibration lamp, a ghost from a mirror surface, a secondary dispersion from a grating, just slightly misaligned, can plant apparent structure that vanishes when the hardware is understood. Teams run through the catalog of such ghosts. Calibration lamps are switched off or changed in sequence. Slits are rotated. Gratings are tilted. Control star fields are observed with identical settings to look for the same narrow lines. The spurious suspects fail to show the same discipline as the object. The lines near the traveler return when the traveler returns and are absent when the slit moves away. Attention turns to chemistry. Metal atoms freed by heat can glow briefly in the ultraviolet, then vanish as they bond or cool. Some industrial compounds on Earth form only at high temperature and under controlled flow, leaving sharp signatures when illuminated. Space is not a factory, but heat and light can still arrange atoms in ways that briefly resemble order. Lines consistent with nickel and with its near neighbors appear in a ratio that stays steady across several cycles of the brightness and thermal rhythm already described. If rare grains forged earlier in distant places are exposed in a crust and warmed, they could shed atoms into a thin plume that briefly reveals their composition before the solar wind carries them off. The timing of these lines earns as much attention as their identity. During the first bright pulse, a narrow ultraviolet feature strengthens then softens in tandem with the light. During the second, just as the object rounds closest approach, a near-infrared ridge grows at the same interval that heat peaks. During the third, the faint metallic line returns even as visible brightness begins to drift downward toward outbound. The lines are not merely present, they are punctual. Cross-correlation maps the cadence with the regularity already found in light, warmth, and jets. The repetition does not imply meaning. It implies discipline in the process that makes the glow. Polarization adds a quiet complementary clue. Light reflected from smooth surfaces and from certain grain sizes acquires a preferred orientation. Instruments that measure this orientation across color find that during bright pulses, polarization swings toward values more typical of polished or layered material than of loose, ragged dust. The shift is small and reversible. It does not argue for mirrors in the loud sense that word suggests. It does imply that the scattering surface changes its character in step with the spectral lines. A skin that alters from rough to fine or a veil of grains that orders itself for minutes at a time would produce such behavior. Each observatory keeps a ledger of doubts. Solar lines can masquerade under imperfect subtraction, particularly near the sun where the background swells and fades. Analysts overplot the solar spectrum shifted to the object's rest frame and remove it again to see if the lines ride on errors that follow the star rather than the visitor. They do not. Atmospheric lines from the Earth's own air can intrude for ground telescopes. These are catalogued and usually broad. In this case, they do not match the rhythms or the narrowness found in the object's light. Instrumental scattered light is always a possibility. It fails the test of appearing where the object is not. Interpretation steps forward quiet and provisional. If the crust contains patches rich in metals that form under special conditions, those patches could expose themselves under stress and retreat when temperature falls. If subtle fractures open and close with regular timing, they could act as controlled vents for specific layers, releasing gases that glow in their own narrow colors. If charged grains organize under the sun's light and the surrounding field, they could create a temporary skin that both scatters and emits in a disciplined way. None of these ideas requires intention. Each borrows the language of management because the data behave as though a manager exists, whether the manager is simple physics under a peculiar geometry or something more structured within the body. The temptation to jump ahead is handled with care. A single narrow line can inspire bold headlines. The community that tends these instruments prefers to keep metal names in lowercase until subsequent nights repeat the detection, and a second facility operating in different weather and with different glass confirms the same stamp. Those repetitions begin to accumulate as the object moves outward and the glare loosens. Exposures lengthen, the corona's grain recedes, the lines hold. They vary in amplitude as they should if geometry and heating change with distance, but their intervals nest within the same rhythm established on the day of closest approach. The broader spectral shape also evolves in ways that support a layered reading. Continuum light from dust remains present but lacks the wild red tilt that would signal a broad plume of large particles. The bands associated with common volatiles appear and then plateau. Against this steady background, the narrow features come and go on their own schedule. The pattern suggests that the general coma remains modest, while specific sites on or near the surface conduct brief organized exchanges with sunlight and heat. By the end of the analysis, Run Spectra have added a new voice to the choir of anomalies without raising the volume of the song. The lines are real within the customs of proof that this field trusts. They appear with timing that joins light, heat, and jets in a shared rhythm. They point, if gently, toward material that is either unusually arranged by nature, unusually activated by stress, or unusually composed under circumstances not often seen. The tone in the rooms where this is written stays calm. The notes say only that composition participates in the cadence and that chemistry may be one of the levers through which the rhythm is made. What these details offer is not a conclusion but a place to rest the next questions. If certain lines rise when the body brightens and warms, and if those lines choose particular directions in the outflow, then the geometry of reflectivity becomes a natural subject. Surfaces that turn, skins that change, and fields that guide can turn composition into brightness in ways that instruments can follow from one cycle to the next. With this in mind, observers prepare to watch how the object's shine evolves after the blaze when the sun recedes and angles soften, and any rearranged surface can reveal itself by the way it answers light. After the blaze of closest approach, brightness should relax.
And the lines
The
settle
ordinary
again
script
as heat
asks for a
diffuses
gentle
inward.
fading as distance grows and as dust settles into a broader, softer fan. Instead, the light from 3i Atlas tightens and strengthens. In the first half-day after perihelion photometry from coronagraph sequences and from night telescopes that regain the field shows an unexpected climb. The rise is not explosive, it is shaped as if a surface has changed the way it answers sunlight. The glow that once felt like diffuse breath becomes more like a single tone, narrow and steady. And for a time, the object shines with a coherence that fits better with a smooth face than with a cloud. The solar and heliospheric observatory's masked cameras, designed to let the corona be seen, catch this shift first as the object edges away from the solar limb. Frames that earlier showed a modest point now record a pinpoint with crisp shoulders. On mountaintops returning to darkness, long mirrors confirm the same change with better seeing. The light curve climbs by a fraction that would be easy to miss on a noisier day and impossible to ignore on this one. Analysts redraw the baseline and find that the increase will not be absorbed by phase effects alone. The angles between sun object and observer change too slowly to explain the pace. Something about the surface has improved its talent for reflection. Polarization follows. During the unexpected brightening, the preferred orientation of reflected light moves toward values that simple models associate with smoother skins and more ordered grains. The swing is small and reversible but lives in lockstep with the climb. Color stays restrained, a sign that the change is not driven by a fresh surge of large dust. Instead of a reddened veil thickening the coma, the data point toward a reconfigured scatterer, a face that has been polished or aligned by heat and field. The lesson is plain without being loud. Far from dimming after the test of the sun, the traveler seems to have learned how to shine more efficiently. Geometry adds a second layer of surprise. The brightest return does not point exactly back toward the sun. It forms a cone whose axis holds a small tilt fixed in time, a 15-degree lean that remains constant over several cycles of the ongoing rhythm. As the object turns, that cone sweeps space like a beam from a slow lighthouse, and when the beam crosses the observer, the counts rise. The cadence, nearly 1 cycle per hour, matches the pulses already found in light before perihelion and in warmth during it. Bright now means pointed, not simply heated. For a while, the object behaves like a reflector kept at a chosen angle. Specularity, the mirror, like habit of a surface, is an old friend in planetary photometry. Icy crusts can flash briefly when the phase angle is kind. Fresh fractures can act like small facets. But such effects usually arrive as one-time glints, not as a repeating pattern that holds as distance grows. Here, the specular character lives for hours, then eases, then returns in shorter breaths, as though a surface that can be reoriented is being set and reset. Deconvolution of the point spread functions from several instruments shows the peak tightening during the bright spells, a quiet signature of a face that has grown flatter and more deliberate. Dynamics listen for consequence. If a surface presents itself to sunlight in a more efficient way, radiation pressure can lend a push. Orbit solvers, now fed by fresh astrometry, taken outside the glare measure a minute drift in the outbound path. The acceleration inferred from that drift is tiny, a whisper compared to gravity, yet it points along the direction picked out by the reflectivity cone. The pace of the drift swells during the bright intervals and slackens between them, an echo of the hour beat that has threaded the entire event. Words remain careful. The notes say radiation pressure modulation consistent with observed phase behavior. That phrasing captures the alignment and leaves intention at the door. Models try on new clothes. A plate-like region, perhaps a crustal field, smoothed by brief melting and refreezing, could act as a weak sail if held near a fixed angle. An organized sheet of grains aligned by charging within the solar wind and by the object's own field could briefly mimic a smooth surface before relaxing back into fluff. A layered skin with emissivity that can be toggled by temperature might swing between states that favor reflection or emission, supplying both the light surge and the thermal rhythm seen earlier. None of these sketches requires an engineer. Each asks only that nature under stress can assemble order for a little while. The steadiness of rotation is the stubborn fact that any sketch must keep. Period estimates before perihelion, sharpened by the pulses, place the spin near a tidy value under 1 hour. After perihelion, the period stays nearly the same, perhaps shortened by a few heartbeats over the day, but without the wobble that broad, uneven outgassing would often bring. If a plate is involved, it seems to ride the spin rather than fight it. If a sheet forms, it seems to spread where it can remain stable. The impression is of a system that discovers balance within motion and then uses it to keep threats away. Careful observers look for fragments. A surface reconfiguration this neat might be expected to shed. Deep stacks from large mirrors under clear air find no debris larger than the limits allow. The coma remains modest, the tail delicate. The brightness change then prefers the language of pose rather than the language of loss. The object is not so much giving more material to space as it is negotiating with sunlight to get more from each photon. As hours pass, the elevated phase softens. The cone narrows and then blurs. Polarization returns to earlier values. The light curve settles into the decline that was once expected to begin immediately after the peak. The return is not a collapse, it is a glide from deliberate to ordinary. If a face had been turned, it turns back. If a temporary skin had been arranged, it relaxes. The respite leaves behind a record of a reflector that was found held and then set aside. This sequence, quiet in absolute terms and vivid against prediction, points naturally toward mass. A body that can change how much light it offers to the sun without changing how it spins presents a puzzle about its area and its weight. Orbit fitting translates brightness into pressure and pressure into motion. In the next pages, those translations begin to conflict. For now, brightness remains the witness that most easily finds sleep, a gentle voice that says only that surfaces can learn and that learning can be seen in the way a small visitor glints as it leaves a star. The community keeps its language simple. Reflectivity reconfigured after perihelion, specular component present during repeating intervals, acceleration aligned with phase function changes. Nothing in these phrases is sure about cause, and that is their grace. They draw a soft circle around the facts and prepare the ground for questions about what lies beneath a skin that can act like a mirror and yet survive a furnace. The object continues outward, a little brighter than expected for a while, then properly faint. Within that brief excess of light lives the suggestion that shape is not always about edges, and that sometimes a surface can be a decision written in physics rather than in plan. Dynamics which translate light and position into force and weight take their turn. The outbound arc is now long enough to let small residuals reveal themselves. Orbit solvers that include the gentle push of sunlight and the modest thrust of gas return fits that are tidy until the post-perihelion brightening is added. With the reflector briefly more efficient, radiation pressure should have pressed harder and bent the path a little more. The sky disagrees. The drift that appears is real, but not as large as the brightness alone would suggest. Area grows in light. Inertia answers as if mass is greater than the glow implies. Observers approach the contradiction from both sides. Photometry corrected for phase and distance yields an effective cross-section that swells during the specular sequence. Astrometry, reduced against quiet star fields, sets the outbound line where gravity would carry a compact heavy core. The two together define a ratio that strains simple pictures. A thin sheet would feel the sun's hand more strongly. A rubble pile of porous rock would stumble under jets and wobble as thrusts come and go. 3i Atlas does neither. It holds its spin with composure and accepts only a whisper of extra speed aligned with the chosen cone of light. The Planetary Defense Coordination Office posts updated ephemerides that fold in the cautious non-gravitational terms. The Minor Planet Center circulates residual plots with the sobriety expected of that ledger. In private working notes, a phrase appears that has no official standing, and yet captures the feeling the numbers produce: hidden mass. It is not an accusation, just a reminder that weight and shine do not always share the same map, and that a shell can be louder than a core while a core does most of the carrying. Thermal behavior gives the first quiet hint of how such a shell might work. The quick response to changing light measured in minutes rather than hours tells of a surface that moves heat sideways easily. A conductive skin, perhaps metallic in places or packed with grains pressed smooth by long travel, could do this. Beneath such a skin, a denser interior could keep the moment of inertia high, damping the small torques that jets often impose. The slight shortening of the spin period seen around closest approach fits that picture. It is a nudge, not a stumble, the kind of adjustment a heavy top accepts without losing its posture. Spectroscopy contributes a second hint. The narrow punctual lines that enter and leave with the pulses suggest that specific layers speak when warmed and then fall silent. If the outer skin contains patches with unusual emissivity, it could alter reflection and radiation without yielding much material to space. If the inner body is richer and heavier, its presence would be felt not in color but in the refusal of the path to bend as much as a light shell alone would allow. The combination does not prove a layered structure. It sketches one that would satisfy the data with the least invention. Radio engineers search for corroboration in the way signals slide past the traveler. In some sequences, the background of solar radio noise produces faint delayed ripples when the object crosses certain lines of sight. The delays are small, almost at the limit of measure, and they are not consistent enough to write as headline. Still, when averaged and compared against geometry, they suggest that different parts of the body interact with passing waves in different ways, as though the outer skin and what lies beneath do not share the same dielectric mood. If a smooth shell encloses a denser heart, such a difference would not be surprising. Non-gravitational modeling, when asked to choose a single vector to stand for the push of gas, keeps finding a direction that lies between the three narrow columns traced earlier. That is the geometry one would design to let thrust cleanly cancel torque, leaving spin intact, while producing a small net speed along the track. Nature can arrive at such grace by fracture and stress alone, especially after the shock of heating, but the result in numbers is the same. The triangle of outflows stabilizes the whole. The core, if heavy, gives that stabilization something to lean against. Attempts to force a uniform body into the fit begin to leave ragged edges. Assigning all of the post-perihelion acceleration to radiation pressure requires an area so large that the earlier thermal response would have been slower and the rotation less steady. Assigning it all to jets demands amplitudes that would have perturbed the spin far more than observed. The best compromise is a gentle mixture of pressure and thrust, acting on a body that resists both with quiet weight. Within that compromise, the reflector may be only a small fraction of the total mass of bright skin that makes the sky think the whole is lighter than it is. Hubble, given a clear lane in the weeks after glare, adds high-resolution astrometry that tightens the outbound curve. The European Space Operations Centre runs a series of forward propagations using those points and finds that solutions with higher mass moments protect the steady period better as distance grows. The effect is subtle and would be invisible in a noisier case. Here it peeks through. Models that place more mass near the center and less in the skin return residuals that relax a fraction. The improvement is slight, but its direction matches the hints from heat and light. No one claims exotic matter. The language remains ordinary: dense interior, reflective exterior, layered composition. These phrases ask only for natural diversity and for the way stress can separate materials with different talents. If rare alloys are present, they may be remnants of formation or products of slow processing under bombardment and cold. If simple metals are present, they may have migrated to the surface under thermal cycling and then pinned there by charging in the solar wind. The shell need not be designed to behave like a shield. It need only be present when heat and light arrive, and to speak more loudly to photons than to gravity. The mass question has a human dimension because it rearranges habit. For years, area derived from brightness has been a useful proxy when multiplied by a reasonable guess about reflectivity. That proxy stumbles here. Observers write this down without disappointment. The record is richer for asking caution of a familiar shortcut. The object continues to give back in ways that repay patience. Its line through space is simple in the large and textured in the small. Its weight is present and real. Its shine is more learned than it first appeared. As the weeks lengthen, the contradiction softens into a working model. The outbound drift settles into the low controlled values that the mixed picture predicts. The specular episodes grow rarer. Polarization returns to comfortable ranges. The non-gravitational term shrinks but does not vanish. Through it all, the spin remains steady, as if the core and the shell have made a peace that survives cooling. What remains in the notes is not a verdict but a phrase underlined once: mass in disguise. It speaks to the way surfaces can mislead, and to the quiet reassurance that gravity still answers to what is deeply there, even when light prefers the skin. Course is the next teacher. With brightness settled into calmer intervals and the reflector growing modest again, the outbound path shows a gentler surprise. Residuals between prediction and position, small on any single night, begin to lean in the same direction when stacked across many hours. The bend is not dramatic. It is the kind of curve that only patience can find. A slow migration of the line toward the broad table of the solar system, the ecliptic plane where most of the planets circle in company. Astrometric teams, now free of the sun's glare and working under darker skies, collect long tracks against steady stars. The minor planet center accepts the fresh arcs and returns elements that tighten with each clear night. The European Space Operations Center propagates those solutions forward and places them beside ephemerides written before perihelion. A thin ribbon appears between them, a lateral drift that grows by small steps. Over days it amounts to a quiet preference for the plane, as though the traveler, having passed the furnace, were easing toward the level ground where orbits share a common inclination. Orbit fitters give the effect a language they can trust. Non-gravitational terms, once placeholders for a vague push, take on character. One component runs along the path like a low tide in speed. A smaller component leans sideways toward the plane. Both breathe with the now familiar cadence that spans a little less than 1 hour. During a bright interval, the along-track push strengthens slightly. Between intervals, it relaxes. The sideways term follows the same rhythm, but with gentler amplitude. The pattern needs no flourish. It teaches by repeating itself calmly. Instruments that listen to the solar wind add a hushed accompaniment. Magnetometers on spacecraft note faint, evenly spaced ripples as the object passes, small pulses that keep time with the photometric rhythm within the limits allowed by distance and by the wind zone restlessness. Particle counters register modest changes that rise and ease in the same cadence as if charged outflow were being released and trimmed by a steady metronome. Such behavior is ordinary in principle and unusual in this degree of order. It is another sign that different senses are hearing the same soft beat. Geometry matters for interpretation. A simple body that vents at random tends to wobble as jets torque the spin. Here the rotation remains steady and the axis precesses only a little slowly in the same sense as the lateral drift. When the 3 narrow columns traced earlier are folded into a model, they form a triangle that adds little net twist while leaving a sum that points gently toward the plane. The rotation phase that brought the specular glints after perihelion also coincides with the moments of slightly stronger drift, as though pose and push were cooperating rather than arguing. Ground-based observers watch the sky confirm the arithmetic. Night after night, reacquisition requires a short correction that grows predictably. Amateur observers working with careful timing and well-chosen fields contribute positions that land within the same corridor as large mirrors. The shared plot thickens until the long, thin bend turns from hypothesis into feature. There is a particular satisfaction in such work. Small differences, disciplined and repeated, build into a view of behavior that would be invisible to a single eye. Conservative explanations keep their seat at the table. Anisotropic outgassing remains the first tool. If vents open in a pattern that repeats with rotation, a gentle, sustained thrust can result, especially if heating and cooling favor one hemisphere over the other. Radiation pressure acting on a temporarily smoother skin can add to this push without adding turbulence. The solar wind can carry charged grains and ions along preferred lanes that help align a weak sideways force. None of these ideas requires design. Together they sketch a system that could achieve a slow adjustment with little noise. Language stays modest. The phrase course correction does not appear in formal notes, but course adjustment does, framed in the grammar of orbital dynamics. The object's inclination with respect to the plane decreases by small amounts each day. The rate slows as distance grows and as specular episodes fade. The trend
Thermal
remains.
expansion
When plotted
sends
against the
fine,
rhythm that has
silent
carried through the
tremors
entire
across
event,
fissures on
the slope
Atlas,
of the
and
inclination
the
trace
lines settle
flattens and
again as
steepens
heat
in sympathy
diffuses
with the
inward.
pulses like breath moving through a steady walk. Modelers borrow an old sailor's image because it helps the mind hold more than one force at once. A patch that can adopt a preferred angle to the sun for many minutes and then relax may act like a simple sail, giving a subtle nudge along the path, and a smaller one sideways if held a little oblique to the light. The three narrow outflows provide an adjustable complement the way a sheet can be trimmed to keep a heading while a steady wind does most of the work. The analogy is useful and no more than that. It does not imply a hand on a rope. It offers a shape for thinking about gentle control born of geometry and timing. As the outbound weeks accumulate, the drift does not pull the object into a bound orbit. Its energy remains that of a visitor. The adjustment is a matter of posture, not capture. Even so, the preference for the plane carries a feeling of economy. The ecliptic is a region where radiation, gravity, and wind find a kind of average. Many bodies that learn to negotiate with those forces settle closer to it over time. The traveler's approach toward this shared table can be read as a search for quiet, for the simplest lane through the inner weather of a star. The practical consequence is straightforward. Predictions for where large mirrors should look each night shift by small increments that favor the plane. Sky charts marked weeks earlier ask for pencil edits. The object rewards those edits by appearing where the updated ephemerides say it will be. Over and over, the handoff between model and sky closes with a satisfying click. Trust grows from such agreement, and that trust becomes the quiet fuel of further work. It lets speculation stay soft while data remains clear. The community notes without emphasis that the same cadence touching light, heat, and jets appears again in motion. The chorus does not demand new words. It asks only that the existing ones be used carefully. Non-gravitational acceleration remains the phrase of choice, with qualifiers that record direction and phase. The numbers are small enough to let sleep come easily and certain enough to earn their place in the ledger. Wonder is present, but it walks rather than runs, keeping step with the method that found it. By the time the drift becomes too small to notice, against growing distance, the field has learned what it can from this phase. A body from far away entered a bright neighborhood, found a position, and left with a path that remembers the encounter. Whether jets alone wrote that memory, whether a temporary skin learned to play with light, whether a layered structure under stress found a balance that acted like craft without being one, the record remains calm and complete. The course adjusted, the rhythm held. The object continued outward along a line that now lay a little nearer to the plane shared by worlds. What remains in the notes is a sentence that sounds simple and carries weight. The outbound solution includes a small, coherent, non-gravitational component directed along the track and slightly toward the ecliptic. It is a description rather than a claim. It adds a last contour to the portrait of behavior drawn since arrival. Ahead lie the human layers of the story, the way records diverge and converge when many institutions see the same event through different windows, and the way a field keeps its voice even when certainty and doubt share the same page. As the traveler dims and the sky returns to its old calm, the record grows louder in a different way. Frame spectra and telemetry now exist in multiple versions, each reduced with new flats, new darks, new background models. Pipelines are rerun, timestamps are audited, ephemerides are recomputed with small changes that matter because the anomalies themselves are small. In such seasons, astronomy becomes a literature. Databases carry addition notes, and every graph has lineage. The habit is healthy. It turns surprise into something that can be checked. Divergence appears first as ordinary variation. One group reports a modest non-gravitational term, stable in direction and breathing with the hour beat. Another group, using a slightly different subtraction for coronal light and a different treatment of exposure midpoints, finds the term smaller or absent in the same interval. A third repeats the analysis and recovers an amplitude between the two. None of these results contradicts the existence of the pulses. All depend on choices made at the edge of glare, where background is not a single number but a living texture. The differences are not a quarrel. They are the sound of method working its way toward clarity. Timing continues to test patience. The minute scale offsets around perihelion remain after reprocessing, yet their exact values drift with decisions about alignment to solar markers and with the handling of onboard delays. Some archives introduce a revised
Near
clock calibration that tightens internal consistency and shifts perihelion stamps by seconds.
Atlas, while its
Predictions
steady motion
change by small
continues
steps
unbroken.
as those revisions propagate. The ephemerides now carry footnotes that identify which clock file and which version of the reduction pipeline lie beneath each solution. The footnotes look prosaic. They are in fact the map that keeps different rooms in the same house. Language adapts in step. Terms that first appeared as careful placeholders gain detail. Non-gravitational acceleration becomes, in some notes, a phase-locked non-gravitational component. Jet morphology turns into a triad of persistent columns. Post-perihelion brightening becomes a transient specular enhancement with fixed cone axis. Elsewhere, for reasons of caution and publication style, phrasing stays broad. Anisotropic outgassing remains serviceable. Temporal synchronization bias stands in for the stubborn minute-scale disagreement. The drift of words is gentle, but it marks the way models sharpen while claims remain even. Institutions express this process in their own dialects. A planetary defense office updates a public table quietly and points readers to a new solution number that incorporates revised astrometry. A solar mission team posts a reprocessed coronagraph set with improved coronal subtraction near streamers, noting that the change strengthens the visibility of narrow jets without altering their angles. A spectral archive adds a flag to identify intervals where metallic lines reached statistical significance, with a paragraph that reminds users that solar contamination grows near the limb. The tone across these notices stays level. The story advances by versioning rather than by announcement. Informal channels contribute their own weight. Amateurs with careful instruments and the will to keep watch assemble open notebooks that show light curves stitched from many nights and continents. Their plots do not carry the authority of institutional calibration, yet they capture the hour beat with a fidelity that keeps step with larger mirrors. Small observatories that publish raw frames alongside reductions attract professionals who value independent checks. The exchange is not framed as validation or critique. It is closer to a tide, a back and forth that lets the same features be seen under different moons. Disagreement concentrates around two places. One is the strength of the along track push in the days after perihelion. Some pipelines stricter about rejecting frames near bright coronal features, return lower amplitudes, and ask radiation pressure to carry a little more of the result. Others comfortable with a wider set of frames measure stronger coherence with the pulses and place more weight on the jets. The other place is the timing offsets. A minority analysis attributes most of the minutes to subtle interactions between changing reflectivity and exposure strategies in auto gain modes, even though those modes were largely disabled. The majority retains a small persistent remainder after such effects are modeled away. That remainder stays associated with the cadence that runs through light heat and outflow. Neither position claims a final word. Both publish their assumptions plainly. The sociology of caution is visible but not dramatic. Preprints are posted with tables that make replication easy. Conference talks adopt the calm of process rather than the flair of headline. Internal memos that once spoke of unusual coherence now press the term into narrower service, pointing at the alignment of multiple channels rather than at any larger conclusion. A few drafts test bolder language and then replace it in revision with phrases that sit more comfortably inside the bounds of what can be proved. The result is not retreat, it is refinement. Data provenance becomes a character in its own right. Plots carry small labels that name the calibration, stars the clock files, the solar models used for subtraction, the exact geometry engine that applied light travel corrections. When a result changes between versions, a short note explains why in enough detail that another team can step through the same doorway and arrive at the same room. The effect is soothing. It reminds everyone that beneath mystery there is work, and that work has a grammar which, when respected, lets different minds settle on the same page. Public interest rises and falls like weather. A few outlets ask whether the object steers. Official answers explain that non-gravitational forces are ordinary for comets, and that this case, though rich, remains inside that family. The explanation is accurate and sufficient. It keeps focus on the work, rather than on speculations that sound larger than the evidence. In classrooms and amateur forums, the conversation returns to how to measure light well, to how to keep time, to how to compare notes across nights. The story educates by remaining patient. By now, a pattern of institutional reverberation has taken shape. A revised coronagraph set strengthens the narrow jets. A new photometric calibration reduces the amplitude of the specular rise by a small fraction. An updated orbit solution adopts both changes and still records a coherent low non-gravitational component aligned with the established cone. The center of mass of the consensus moves little while the edges gain texture. It is a sign that the field has found the right scale of description. The traveler remains an object with a rhythm, with jets that prefer a triangle, with a skin that learned to reflect more efficiently for a while, with motion that remembers the hour beat and leans toward the plane. If strain exists, it is the productive kind, the quiet tension that holds a net taut enough to catch what falls into it. Some would like to declare a mechanism. Others prefer to let the verbs stay general. Between them is the shared work, the releases that cite exactly how they differ, the footnotes that show how a minute moved from one column to another. The culture is not a single voice, but it is a single pitch. It stays even. It treats evidence as a guest to be given time. What the reverberations leave behind is a record that the future can trust. Raw frames remain accessible, reduction scripts are archived, clocks are documented, versions are named in ways that permit memory to be precise. The traveler moves outward and will soon be too faint for most eyes. The files will remain, and within them will sit a modest set of surprises that refuse to be erased by reprocessing. The consensus that emerges is not dramatic. It is a paragraph that many consign a visitor past near the sun, answered with a rhythm seen in light heat and jets, shone more efficiently for a while after the peak, and drifted outward with a small coherent adjustment toward the plane. The rest stays open, which is a good place for hard questions to rest. The object grows fainter with honest steadiness. Exposure times lengthen. Telescopes switch to slower cadences that trade immediacy for depth, gathering long, thin streams of photons that began their trip when the traveler still wore the glare of the sun. Cometary name remains in use because taxonomy prefers consistency, yet each new night reminds observers that this visitor has written a different stanza. The hour beat that once shaped light heat and jets now appears only as a suggestion, a gentle swelling and easing that demands stacks of frames to be seen at all. The triangle of narrow outflows relaxes into plumes that behave the way most plumes do in generous space, broadening until their edges forget where they began. Archives carry more weight than images at this distance. The Minor Planet Center continues to receive positions from large and small observatories, each reduced with the care taught by the earlier surprises. The Jet Propulsion Laboratory and the European Space Operations Center keep their orbit solvers warm, even though the non-gravitational term now breathes so lightly that it can be described without adjectives. The International Asteroid Warning Network, which hosted coordination and quiet assurance during the approach, now emphasizes custodianship, making sure raw frames, time standards, and reduction scripts remain findable. The emphasis shifts from watching to remembering well. What remains in the active sky still matters. Polarization tends toward ordinary values as the temporary specular skill of the surface fades. Spectra return to the comfort of dust and common volatiles, their narrow metallic whispers now only occasional, as if layers that once spoke have closed their mouths and turned inward to travel. Thermal curves measured from instruments that can still separate ember from furnace draw the smooth hill that models always preferred, a sign that the fever has passed and that cooling can proceed without rhythm. The object feels more like other visitors now, which is to say it feels familiar enough to be held without effort. And yet, the file does not forget. Non-gravitational acceleration remains recorded as a coherent low component that favored the outbound track and leaned by small and steady amounts toward the ecliptic plane. The phase-locked modulation of light and heat endures in plots and in memory, not as a flashing tale, but as a calm pattern seen by many instruments from many places. The three narrow columns remain in deconvolved coronagraph sequences, precise and modest positioned like points found by a steady compass. The post-perihelion brightening holds its place as a careful paragraph about a surface that learned briefly to answer light with unusual poise. Each piece stands alone. Together they form a portrait of behavior that is more coordinated than expectation and less theatrical than myth. Interpretation hardens only where it must.
Thermal expansion
Anisotropic
sends
outgassing
fine,
explains thrust
silent
without invoking
tremors
attention
across
beyond
fissures
physics.
on Atlas.
Radiation pressure helped
And the
by a
lines
temporary
settle
smoothness in
again
the
as
skin
heat
adds a gentle
diffuses
push
inward.
aligned to pose. A layered structure conductive at the surface and denser within accounts for the quick thermal response, for the steadiness of spin under stress, and for the mismatch between area that shines and mass that carries. Fields in the solar wind felt by charged grains at close range draw the narrowness of the jets and help keep their angles true. These explanations, plural and interwoven, do not ask for intention. They ask only for material that takes order from heat geometry and time. A quieter possibility sits nearby, neither demanded nor dismissed. When many channels hum on the same cadence, when geometry keeps its manners through weather, and when a surface seems to find a preferred angle and use it repeatedly, minds turn toward the idea of systems. Systems can be natural, born of fracture patterns and feedbacks that smooth themselves. Systems can be made. The word artifact does not appear in formal conclusions. It hovers only as a lens some choose to try on for a moment and then set aside, not because the view is forbidden, but because the view cannot be proved. The culture of this field finds comfort in that restraint. It knows that wonder lasts longer when not hurried. The human story around the object has found its balance. Early excitement yielded to careful work yielded to shared puzzles yielded to versioned answers, which in some leave the ledger clearer than it began. Corrections are written down and owned. Disagreements are documented and bounded. The narrative does not sharpen to a point. It broadens into a place where future objects will be met with better preparation and more generous baselines. That is the quiet profit of an encounter like this one. It leaves behind a way of seeing that will serve bodies yet to appear. Spacecraft that helped through glare return to their usual duties, watching the sun and its weather with attention undiverted. Ground facilities fold the fading target into twilight lists, observed when air and time permit. A few programs keep longer integrations running, harvesting the last grains of signal as the traveler leaves the reach of all but the largest mirrors. Hubble contributes a final set of precise positions that refine the outbound solution one more step. The European Southern Observatory closes its series with a night of clear air under a tilted moon color and polarization checked once again for completeness. The cadence of attention, once fast, now stretches to the scale of weeks. In the literature that follows, careful sentences do most of the carrying. A visitor from beyond the sun's bound path passed near Perihelion. Its light and heat displayed a repeating cadence of small pulses. Its outflow drew narrow columns that kept fixed angles. Its surface reflected more efficiently for a while after the peak, with a cone of specular preference held at a steady lean. Its course included a low-coherent, non-gravitational component that favored motion along the track and slightly toward the ecliptic plane. Its spin remained steady. Its mass presented itself as greater than a bright skin alone would imply. Each clause stands on data that survived reprocessing. Each avoids saying more than it knows. Meaning, if the word is allowed, rests in how the record changes future practice. Observers will keep raw frames longer and cross time standards more often. Chronograph fields will be planned with narrow jets in mind, not only with broad plumes. Spectral campaigns will reserve exposure for subtle metals and for small swings in polarization that hint at skin and grain. Orbit solvers will treat phase-locked non-gravitational terms as possibilities rather than as rare exceptions. None of these adjustments seeks drama. All seek fidelity so that the next time rhythm visits the inner system, the score can be read with even less doubt. The object continues outward, its path remains open to the galaxy. If it learned in light how to hold a posture, that knowledge now retires to the cold, where such skills offer little advantage. If it is only stone and ice cleverly arranged by heating and stress, it travels as a refined example of what matter can do under a star. If it carries layers that once met light in disciplined ways, those layers now rest. Telescopes turn to other work. Files rest on disks and tapes. The story pauses without closing. In the end, the lasting image is modest. A small body approaches a star, answers with a pattern that can be written without exclamation, and leaves behind a map of gentle anomalies that invite future travelers of the mind to linger. The night regains its quiet. The plane of the planets lies broad and patient. Somewhere far outward, a point fades and joins the common dark, carrying whatever it carried in, whether secret or simple, whether system or happenstance. The record remains, and in that record, a rhythm continues to breathe slow and soft like a tide heard from far away.